Hey Valley Metal, welcome back to another G67 math video. Tonight we're going to be finding the scale factor and using it to solve problems. Before we do that, let's start off with a scale factor related trivia question. Is this real? Is this legit? Is this a real Major League Baseball game? That's certainly what it looks like. Is it the real thing or not? I'll be back with the answer to that after instruction. Tonight, officially, our target is I can find the scale factor and use it to solve problems. Let's do this thing. Have you ever wondered how engineers build this beautiful stadium, giant, from this small model or from a blueprint? Or how engineers build this model from this giant tractor? Well, if you have, you've thought about scale factor. For example, this model is 1/16th the size of this tractor. Or we can look at it this way. This tractor is 16 times larger than this model. Let's learn a little bit more about scale factor when we talk about similar figures. Similar figures and ratios, these are two important words you have to understand in order to understand what we're going to be doing tonight, finding scale factor. Similar figures are any two geometric figures that have corresponding angles that are equal. This angle B is equal to its corresponding angle E. See the two little lines showing that they're the same? Look at angle A. 1 and 1 here, showing that these two are equal. 3 over here on angle F and 3 on angle C. They're similar if their corresponding angles are equal and their corresponding sides are proportional. Look at this side is 20, this side is 10. Looks like they're doubling. This side is 6, this side is 12. This side is 7, this side is 14. This one here is 1/2 the size of this. Or this triangle, it's similar. Its angles are equal. All of the sides are twice as large. It's 2 times the size. All right, we've already started talking about proportions and scale factor. It's also important to remember that ratio is a comparison of two quantities or parts. Remember, when we're going side to side, we're talking about part to part. And top to bottom, like 2/5, that's that fraction, part to whole. All right, so we're going to be using finding scale factor and using scale factor tonight. Let's start with finding scale factor. Let's look at these two problems here. Actually, these two shapes here, these two pentagons. Notice that we have a missing measurement here, but it doesn't matter. We just need two corresponding sides with measures to determine the scale factor. So I'm going to take this the top left roof of this pentagon and the top left of the roof on this pentagon. I'm going to pop them into a ratio proportion box. Here's the small one, here's the large one. I'm going to throw a unit rate down in here of 1. 6 inches is to 18 inches, like 1 inch is to multiply diagonally, divide across, you remember how to use the box, is equal to 3. What they're saying is that, it's right here someplace, starting with the small one, this is 1 to 3, 1/3. This one over here, it's right here someplace. Gotta find it. Don't give up on me. It's not there someplace. I could click in. It'll say that this one is, it's up here, is 3 to 1. Starting with the large scale, it's 3 to 1. Notice that they're reciprocals. Large to small, it's 3 to 1. Small to large, 1 to 3. Interesting, isn't it? You're using a ratio proportion box to do this. We've done this before. You can see how this all works. You understand. This is going to be a good lesson tonight. All right, let's take a look at another example. Looking at these two quadrilaterals, we have a side of 2.45 and one of 4.9. Let's use them to find the scale factor. We choose corresponding sides. We pop them in the ratio proportion box. The small and the large. Notice I always like to label things to keep my measurements straight. So 2.45 inches to 4.9 inches. Throw in a 1. 1 times 4.9. Divide across. 2. 1 to 2. Where are they? I always have trouble finding them. Here we go. This is 1 to 2. Starting with a small one. The scale factors are less than 1. Okay, going from small to large. Starting with the large one, it's going to be greater than 1. This one is greater than 1, so this will be 2 to 1. And again, they're reciprocals. All right, time for you to try one. See if you can find the scale factor of these two vases. This is 15 centimeters and 45 centimeters. Yeah, you only need one measurement. All right, let's see how you did. Well, I just made my little ratio proportion box. I put the large and the small. I kept them just like this, so I flipped my large and small. So it's 45 to 15. I want to know what 1. So 45 is to 15 is something is to 1. Multiply diagonally, divide across. 1 to 3, 3 to 1. They're reciprocals again. 3 to 1. Starting with the large one, the scale factor is greater than 1, 3 to 1. Starting over here with the smaller one, it's less than 1, 1 to 3, going from small to large. All right? Now that we've learned how to find scale factor, let's find it one more time, and then we'll use it to find the missing side. So on these two rectangles here, it's 20 centimeters to 15 centimeters. Well, given two corresponding sides, I can pop them in, I can find out what that scale factor is. I could even use 20 to 15, but what I did here is I took the 20 to 15 and I simplified it into a simplified ratio. So I divided each side by 5. This divided by 5 was 4. 15 divided by 5 was 3. And I just put them in a ratio proportion box to make sure the cross products are the same. We've got 60 going this direction, 4 times 15, 20 times 3. That's 60 as well. So here's my scale factor for this, 4 to 3. So my large is 4, my small is 3. I put in the measurement of the corresponding side that I want to find. So now I'm putting in 5 centimeters on the small one. I want to find this one. I put those in my ratio proportion box, large to small, like something is to 5. Multiply diagonally, divide across. I've got 6.6. 6.6 centimeters. It's there someplace. There it is. 6.6 centimeters is the measure of this side. I did that finding the scale factor. Again, I could have just popped in 20 and 15 and put the 5 down here too. So I can use two other sides, or I can find the scale factor. The scale factor is going to be this and this in the simplest form, or the ratio in simplest form. Okay? 20 is to 15, just like 4 is to 3. All right? All right. Let's go back to that John Deere tractor question. Remember this one here? Well, let's say that we wanted to find the measure of this wheel here. I told you I had that tractor, so I went down to the basement, dug it out, and I measured it. The measurement of that wheel is 4.5 inches. So I set up this ratio proportion box. I know that the scale of that tractor was 1 to 16. Remember I told you that? So the toy to the reel is 1 to 16. That's my scale factor. On the toy, the wheel is 4.5 inches. Multiply diagonally, divide across, 72 inches. And think about it. This guy's probably 6 feet tall. If the wheel is 72 inches this way, it's round. It's got to be 72 inches this way. Makes sense. Nice. All right, time for you to try one. Don't give up on me here. On this blueprint here, I want you to find this measurement here. Now here's a blueprint, and here's the actual house. On the blueprint, it's 8.5 inches. You need to find this measurement. And the scale factor is 2 inches is 5 feet. Go ahead and pause the video and give it a shot. All right, let's see how you did. Well, I laid it out like this. Blueprint to house, 2 inches to 5 feet is like 8.5 inches to something. Multiply diagonally, divide across, 21.25 feet. Okay? Maybe you did something different. Maybe you put it into a unit rate. You could have simplified this and said, well, if this is 2 inches to 5 feet, that's also 1 inch to 2.5 feet. 1 inch to 2.5 feet is like 8.5 inches is to how many feet? Multiply diagonal, divide the other way, still 21.25 feet. It's the beauty of the box.
Strong be the Jedi that understand the box.
Don't ask. All right, here we go. So find the scale factor and find the measurement, the missing measurement. So here it is, and you need to find this measurement. You've got some sides here. Go ahead and find that scale factor using corresponding sides and find out what X is. All right? All right, thanks for listening. Good. Oh, you want the trivia question, don't you? All right, and how it relates to scale factor. All right, Is this real? Is this legit? Yes, it actually is. This guy's name is Eddie Goodell. He's 3 feet 7 inches tall. He was hired on a 1-day contract by this guy named Bill Veeck. I can't remember when, a long time ago, early 1900s, to play baseball for the Browns. They send him up to bat. He's 3 foot 7 inches tall. The pitchers are the other coach is going crazy. Of course, the guy has to be pitched to. He's the batter, but his strike zone is so small from chest to knee or chest to belt buckle in here in this range here. His strike zone is so small. The pitcher walks him on 4 pitches. The guy goes to first base. He's immediately taken out of the game, but he goes down in history as, being this little tiny guy that Bill Veeck, the owner of the team, who did all these crazy stunts to get people to come to baseball games, like putting Eddie Goodell in the game. It's just fun part of baseball history. Interesting, Bill Veeck's son, Mike Veeck, is part owner in the Saints, St. Paul Saints, or he used to be. And, the Saints motto is fun is good, they used to say. So they do a lot of crazy things at the Saints games to make baseball fun, too. Now you're wondering how this relates to scale factor? Guess what Eddie Goodell's number was? Your dads or moms might know. 1/8, it said on the back of his jersey. Kind of funny, huh? I knew I'd tie that in scale factor. All right, thanks for listening. Have a great evening.